Hi everyone, let me start by introducing you to PCB Coffee Talk, a place where you can listen in while we chat with PCB experts sharing valuable information and tips related to PCB design. While we chat, we hope you can enjoy a good cup of coffee, learn something new, and leave with a better understanding of today's topic. Our goal is to keep these sessions fun and easy to understand. I am Tara Dunn with Omni PCB.
And I'm Elizabeth Foradori with Omni PWB. We're a technical manufacturers rep group specializing in printed circuit board technology. We have a combined 40 years experience in the industry working with flex, rigid flex, and rigid PCBs. We have realized that there's an interest throughout our customer base to learn more about PCB design elements, but that there's no time available for long, detailed training sessions. We started this PCB Coffee Talk series to explore various PCB topics in short, 10-minute segments. Each session is recorded so that you can view it at your convenience.
Today we're going to be chatting with Mike Vincent with Veritech. Innovations in advanced electronics in all markets are driving printed circuit board designs to higher density and higher data rates in 3 dimensions. Veritech has developed an additive process for both rigid and flex materials that enables geometries less than 25 microns and thin copper designs less than 5 microns. When the traditional subtractive etch process hits processing limits and is no longer reliable, this technology can be a logical next step. Mike, to get us started today, could you please explain the technical capabilities this process has been proven to achieve?
Yes, thank you for having me today, Tara. One of the first areas that we worked on with this new technology was in the fine line region, below 25 micron lines and spaces. We've done this with an additive process in the rigid and flex area as well as semi-additive. The precursor ink makes all of this possible by producing a very fine layer that we can build up on, and this fine layer is able to be patterned into very fine features. The next area where we've seen excellence is in the via area. We found that because the ink penetrates very well into the surfaces and the voids, it gets into the vias exceptionally well, providing a very good precursor for plating up at the next steps. Because it creates a more uniform catalyst layer, it uses much less electroless copper and therefore reduces cost in the electroless copper area. The third area that we looked at was the stacked microvia. As you can see from the picture, the penetration into the corners of the microvia has been excellent. This gives us very good penetration down to the lower layer, as well as good adhesion to the sidewalls. And lastly, we have been used in the area of selective via plating. Because in the multi-layer rigid PCBs, the precursor ink is blocked in certain key areas, and this provides a significant cost savings over the conventional methods of up to 60%. On the next slide, you can see a little bit more about the vias where the additive process has improved plating. You can see that the the ink provides a method to plate back into any kind of horizontal layer. We get good adhesion throughout the layers, and we can do this by plating a very thin layer of electroless copper and still providing a very good base for electroplating. In the blind via, we've also found that we can achieve high aspect ratios by getting down into the via with the plate with the ink, and the electroless copper also is plated up very thin in these areas. Because there's no organics involved or residue left from the ink, the adhesion to the subsequent copper layer below has always been very good.
Mike, your additive process is based on a special catalytic precursor ink. Can you please explain how this ink is processed and what makes it unique?
Sure, Elizabeth. Let's talk a little bit about the precursor. When we look at conventional processes, we took some literature and some local knowledge about colloidal palladium. We found that the colloidal palladium particle was 26 times larger than the average atomic layer of Veritech. So on the next slide, you can see that these colloidal chemistries are being laid down at a much larger scale, and there's also a tooth that's needed to be put into the substrate so that the subsequent electroless copper can get a purchase into the substrate. With the Veritech precursor ink, we put down a tightly packed uniform layer, very, very thin, and very little separation in this layer. So this uniformly spaced nano layer gives us a very tight production of the next layer of copper. And on the next slide, we can see how the copper builds up, forming the Veritech ink on the bottom versus the conventional colloidal plating on the top. This colloidal plating forms a fluffy layer at first, and then it forms a more solid layer of copper afterwards. With the Veritech ink, we get a very dense layer of copper almost instantly from the precursor. When it comes to selective plating, we find that we can produce a blocking material that neutralizes the catalytic layer. With colloidal palladium, when the colloidal particle touches the neutralizing layer, it only gets neutralized in a very small spot. But with the Veritech atomic layer, we get uniformly blocked area where the blocking material exists. So with the Veritech approach, we can get very uniform blocking of the catalytic material. So on the next slide, it shows taking those previous slides and putting them together. You can see how the pattern is formed with blocking material using the Veritech approach versus the colloidal particles, which are still placed a large distance apart, but don't really have any kind of blocking promoted with them. On the next slide, you can see then how the colloidal particles will still promote plating, even though that they're sitting on the top of the blocking material, whereas the Veritech ink will be deactivated on the blocker, therefore allowing a pattern to be formed, whether it's a pattern that's indicated inside the substrate or on top of the substrate.
Mike, what materials are compatible with your process, and what advantages does this process have beyond the fine lines and thin copper?
So we've been able to plate up on a number of different materials, such as polyamides, polyesters, epoxies, some molded polymers. We've been doing work in the 3D molded area where we're able to plate up into very tight spaces. In the ceramics, we can get some degree of penetration into the surface of the ceramic. We're also plating on things such as fibers, so that to get a very, very thin layer of copper upon the fiber without really any patterning needed, we can maintain the flexibility of the fiber and still give it a conductive layer on top. So these printing techniques we use can include inkjet, gravure, pad, screen, or UV or lithographic, but the other advantage that we see there is the ability to either plate selectively or either selective plating or selective non-plating, which allows us to do some very interesting things in the third dimension, or the z-axis.
Mike, thank you so much for sitting down with us to discuss the Veritech's additive process. You've provided great information. We hope that everyone enjoys this session and that we were able to provide information that will help you with your board designs and purchases. Of course, you can call Tara or me at any time, and we'll be happy to answer your questions. If we don't have the answer, we'll contact one of our experts and get you an answer as soon as possible. Remember, buying printed circuit boards should not be difficult.